All right, we're in section 7.6 where we are going to apply sine and cosine ratios. So in 7.5, we talked about tangent, and tangent was when you had an angle of a right triangle that was other than the 90-degree angle, and you were able to solve uh, that using opposite over adjacent. When we look at sine, we are looking at, so right here in this particular instance, we have sine of A, so we have angle A is going to be theta, so it's going to be some angle measure. And if you look here, the sine of A is going to be, in the numerator is BC, which is, in this case, is the opposite over AB, which is right here, which in this right triangle, or in any right triangle for sine, it is going to be the hypotenuse. So anytime you're looking at sine, we are going to be dealing with opposite over hypotenuse. If you look at the other sine uh, ratio, sine B, the opposite of sine B is AC. If you look right here, and then the hypotenuse is still AB. So again, it's still opposite over hypotenuse. Now cosine, if you look at cosine here, cosine of A, so we got A theta, is AC, which in this case is the adjacent side of the angle, and AB is still hypotenuse. So cosine is adjacent over hypotenuse. Same thing goes for cosine of angle B. The adjacent is BC, and the hypotenuse in this triangle is still AB. So what they're asking us to do in uh, in these examples, first off, is they want you to find the ratios of sine x, cosine x, sine y, and cosine y. It's asking us to write each answer as a fraction and as a decimal. So they want us to round to 4 decimal places if necessary. So let's look at both sine uh, sine values, the sine of x and the sine of y. So if we look at sine x, that's going to equal the opposite, which is 8, over the hypotenuse, which is 17. All right, 8 over 17 can't be uh, simplified any more than that. And the decimal form of this, rounded to do 4 decimal places, is 0.4706. Okay, so that is the sine of x. So now let's look at the sine of y. So the sine of y, which is right here, opposite in this case is 15 over hypotenuse, which is 17. Okay, 15 over 17 is in simplest form. And if I'm to write this as a decimal, it's going to be 0.8824. Okay, so got done with the sine of x and the sine of y. Let's look at cosine of x and cosine of y. So cosine of x is adjacent, so that's 15 over hypotenuse, which is 17. Okay, and we actually have something here. The sine of y is actually the same ratio as the cosine of x. And so it's going to be 0.8824, which probably means that cosine of y is probably the same as sine of x, but let's check. Cosine of y adjacent is 8, and hypotenuse, which is 17, and again, it's 0.4706. 0.06. Okay. So in these situations, they want us to find both x and y. So looking at the first triangle to our left, we are given an angle measure of 64 degrees. We know it's a 90-degree angle, so it's a right triangle. And they give us the hypotenuse, which is 55 feet. So, doesn't matter which one you choose first. Solve for x over y doesn't make any difference. So, using the trig ratio, let's look at x first. So, x in this case is the opposite um, of our 64-degree angle, which means that we are given the opposite of the 64-degree angle. We're given the hypotenuse. So to solve for x, we need to find the sine of 64 degrees, which is going to be opposite, which is x, over hypotenuse, which is 55 feet. Multiply 55 to both sides. So now I have x is going to be equal to the sine of 64. Again, when you write this in with your sine of 64, make sure that your mode is in degrees. We talked about that in the previous video. And then multiply that by 55, and I get a value which is about 49.43 feet for x. Now to find y, with the 64, I'm going to use the adjacent over hypotenuse, which is cosine. So now I can say that the cosine of 64 is going to equal y over 55. Same thing, multiply 55 to both sides. I got the cosine of 64, and then multiply that by 55, and it's telling me that 24.11 feet is going to equal y. One way you can check this, I know with approximations and stuff like that, I want to see if, the square of 24.11 plus the square of 49.43 is close to 55. So if I did that, so 24.11 square that gives me 581.2921. 49.43 squared is 2,443.3249 plus, so I'm adding those together, and that gives me 3,024.617. Take the square root of that number, and I get 54.99, which is really close to 55. So with my approximations, it's not going to be exactly 55, but it's something close. That's just a way that we can check our answers. Looking at the triangle to the right, we have a right triangle. We have one of the angles is 26 degrees, and we are given a hypotenuse, which is 37 meters. Same idea. All right, I got the opposite over here, so I can use the sine of 26 is going to equal x over 37. Again, multiply 37 to both sides. The sine of 26, calculate that out, multiply it by 37. I get 16.22 meters for x. To find y, I got the adjacent, so it's going to be cosine of 26 equals y over 37. Multiply 37 to both sides. Again, cosine of 26, multiply that by 37. I get 33.26 meters for y. And again, you can do the same thing with the Pythagorean theorem to check and see if it's close to 37 as your hypotenuse. Okay? And that is being able to apply sine and cosine ratios. Hope this helps. Until next time.